Hi, everybody. Today is Monday, September 12th, 2022. I am man who has not recorded a video in 3 days, but has a clean apartment and a vacuumed floor, so that's good. Before we get into our lesson today, I want to do a little bit of follow up into the last video. In that we learned about enums and we worked on the boutique inventory exercise, and we had left it at iteration 3, and the Elixir analyzer was complaining. It was complaining that I should use captured notation instead of creating a new anonymous function. And when I read this, I kind of took it to be like it was complaining about the general concept of anonymous functions, and I kept going into things trying to replace my use of them. And I thought it was kind of complaining about, this kind of thing where like I was creating enum into and I was passing it a function. That's weird. I don't see those 2 arrows there. But oh, that's because it's down there. Oh, that's weird. I would have thought the formatter would have put it up there. Anyway, the problem was not there. The problem was down here, and it was extremely explicit in saying that you should be using this captured function instead of creating this anonymous function. And so what I've done is I updated my iteration to do that, and so now we just pass in. We just capture the addition function there, and it kind of works, and I get no analyzer warnings, and that's good. So with that out of the way, today we're going to be talking about binaries, so we're going to break into that. Cool. So Elixir provides an elegant syntax for working with binary data, as we have seen with the, I don't know how I would say that out loud, the special form, I'll just say the binary special form, provided by working with bit strings. The binary type is a specialization on the bit string type. When our bit strings could be of any length or any number of bits, binaries are where the number of bits can be evenly divided by 8. That is, when working with binaries, we often think of things in terms of bytes or 8 bits. A byte can represent integer numbers from 0 through 255. It is common to work with byte values in hexadecimal, where you express them as 0x00 up to 0xFF. Binary literals are defined using the bit string special form. When defining a binary literal, we can use integer and string literals. Integer values greater than 255 will overflow, and only the last 8 bits of the integer will be used by default. The binary modifier is applied to the value. We can concatenate binaries with the bracket less than greater than operator. Cool. All right. So yeah. So they're demonstrating some binary syntax. So basically, we can say inside of this value, we're representing the binary value of 255, and that is also equal to this value, which is 0xFF, meaning that like you can represent these as either with integers or hexadecimal values. If you use 256, it will overflow, so it'll use the overflow value, which in this case is 0, so that will be true. And then in this case, 2, 4, 6, 8, 10, 12, 14, 16. Yeah, so they're just giving you kind of a demonstration of what hexadecimal looks like. Cool. A null byte is another name for 0. Okay. Pattern matching and binary data. Pattern matching is even extended to binaries, and we can pattern match on a portion of a binary data much like we could for a list. Ignore the first 8 bytes, match and bind the remaining to body. So it'll grab the first, it'll pattern match. So if you had a value on this side, it would pattern match into this, and then the very first 8 bytes would be captured into an anonymous value with using the underscore. Then the rest would be captured into a variable called body. Like with other types of pattern matching, when you can use this in function signatures to match when selecting from multiple function clauses. Cool. So yeah, this is this binary pattern matching is really valuable for like file like types. So like it's not uncommon to get like a blob of data from a web connection or a hardware device, and you kind of want to like cherry pick out the headers versus the body, and then you'd process the headers a certain way. Um, I've done this type of thing a lot with that. So, all right, cool. So we're going to be working on an example called File Sniffer, and we're going to learn one concept. You have been working on a project which allows users to upload files to the server to be shared with other users. You have been tasked with writing a function to verify and upload matches its media type. You do some research and discover that the first few bytes of a file are generally unique to that file type, giving it a sort of signature. Use the following table for reference. So file type, ELF, bitmap, ping, JPEG, GIF, media type, binary signature. Interesting. To actually give you that right there. Cool. All right, so let's download our exercise and get going here. We're gonna cd into that, and we'll open it up in VS Code. So I'm gonna open up my library there, and we'll put the test file up here, and we'll put the README down here. And we'll hide the source file, or the, not the source, but the browser, whatever you want to call it, the file list. All right, so let's see here. We may need to reference this, that list there, so we'll say. Given an extension, return the expected media type. Implement type from extension function. It should take a file extension string and return the media type string or nil if the extension does not match the expected one. So for example, given the string exe, you should return application. Okay. That looks fine. So we'll do a case, and we'll say given the extension, we'll pattern match the list here. So let's open up the list and keep an eye on here. So for exe, it's going to be this. So exe and bmp is going to be image bmp, and png is going to be image png, and jpg to be image jpg, and gif or gif, start a culture war there. It's going to be gif. Okay, and then we need to capture something. We'll just say nil. Okay. Cool. I'm actually going to put it in the type spec. So this is going to accept a string, and it's either going to return a string or nil. Cool. All right, let's see if we can run some tests. So Elixir test, run test at cursor. That looks good. All right, let's do number 2. Given a binary file, return the expected media type. Implement type from binary. Oh, I wonder if they implemented this, if their intent was to implement this as function captures. Anyway, we might change that later. It should take a file and return the media type or nil if the extension does not match. So, so given this or this, okay. Oh, okay. So they want us to capture the last 3 characters. Don't worry about reading the file as a binary. Assume that has been done for you, provided by the test as an argument. Okay. I wonder. All right, so let's go back to our concept doc. And you can see that like this was a binary and they were capturing the first 8 bytes. What we could do, I believe, is we could capture the last 3 bytes. Capture it as, yeah, I don't think that'll, extension. Only allowed at the end of a binary pattern. Oh. They're kind of like giving us the thing there, rest foo. I mean, this is one way you could do it. You could say do. Actually, this is probably the better way to do it. Extension, and then type from extension. All right. So this will take in an element. It will pattern match on this. We'll just ignore the file name. We don't really need it. Get type from extension, return null, it doesn't match. Did we validate that? I don't think we did, actually. Inside match should always be a literal binary because its size can't be verified. Yeah, I don't think that's what they want us to do. It's weird. I don't even consider this like file naming, it's like string matching to be binary, but it is. It should take a file, binary, and return the media type, string, or nil if the extension does not match. Don't worry about reading the file as a binary. Assume it has been done for you and is provided by the test as an argument. Yeah, that's weird. I don't like how they give you a file name. They're like, pretend this is contents of a file. That kind of throws you off a little. Oh, whoa. That's not actually what it is. So they're actually, okay, they're reading. Oh, they're like pretend. Oh, geez. Yeah, I'm like way off here. Way off here. Okay. So yeah, so this is the binary. Okay. So let's see here. So yeah, so this would just be like if it's an exe, it should pattern match that. Okay. So So yeah, so we'll just do the binary type, and then we'll capture the body. Okay, so for this one, which is the exe, it'll be that, and then a body, which will just be binary. And then that would return what do I need to return here? So given this binary stream, then return that. So that would return type form extension exe get type from binary. Let's run this test and see if any of these pass. Cool. So some of them pass. Does the exe one pass? Yeah, exe does pass. Okay, so we are on the right trail here. Okay, so we'll just build one of these for each type we want. Okay, so this one is 042, and that's going to be BMP, and this one's this. Put that in there, and then this is going to be PNG, and this one is going to. I missed one. This one's going to be JPG, and this one. GIF. Okay. Cool. They look good. Okay. I think that's supposed to return nil, right? If it's not there. Yeah. So did they test that? Get type from binary return nil when given incomplete signature file. Yeah, this is gonna fail. Yeah. EL. Alright, we'll just define type from binary, and we'll just capture everything, and we'll say return do nil, and that looks good. Oh, it fails. BMP. Returns nil when given incomplete signature. Yeah, I think I missed. Yeah, BMP is. My wrapping is confusing things. So BMP is this header, not just 42, but 42, 42D, 4D. Alright, that looks good now. Okay. Alright, let's see. Number 3. Given an extension and a binary file, verify that the file matches the expected type. Implement verify. It should take a file and an extension and return OK error tuple. Warning file format system match. Okay. So let's see here. If type from extension. I mean, if type from binary file binary and type from extension. Okay, and then type from extension again, although that's very that's very excessive. True can never be the type. Why? Is it any? All right, let me run the tests. Bad boolean. Expected a boolean on the left side and got. Oh. No, I don't want and. I want equals. Cool. That looks good. This is kind of like excessive. Like you don't want to generate that twice, so that's a little bit more I'm going to do it this way. That'll work. I don't know. There's probably a cleaner way to do that with like a case statement or something. But I think this is good for now. All right, cool. Let's upload it and see what the internets have to say. That looks good. Take a peek at the community solutions. This person heard a module talk. That's awesome. I love that. They also defined a module attribute describing the types, talking about the extension, the media type, and signatures. That's great. That's very clean. I love that. They put a document. This is great. I'm going to give them a star. How do I give them a star? How do I star them? That's weird. I like. Oh, there it is. Star. Yeah, I'm giving them a star. That's awesome. If that, do else. So that's great. Love that. This one similarly created a little source of knowledge. And then said find. That equals that. Extension. Wow. So they're doing the pattern matching inside of the function with a case statement, and that's fine. I would say the Elixir norm is to pattern match in the argument list, but it's the same kind of concept. There's pros and cons of doing it either way. I mean, one nice thing about having it here is that like you are in one little encapsulation, capturing all of like the logic decisions, whereas like if you're doing them as function pattern, like argument pattern matches, you can get lost in the shuffle a little bit. I don't know, but this is good. All right, cool. So I'm pretty satisfied with this. We're gonna mark this as complete. We're gonna publish our solution, and all of a sudden we have learned binaries. We've unlocked 5 new exercises, and yeah, and we will do more tomorrow. That's it for today. Hope you enjoyed watching. If you have any questions or feedback, definitely let me know. Other than that, I will see you next time. Bye bye.